Time feels permanent. Every second moves forward, clocks tick, stars age, and galaxies evolve. But physics suggests time is not guaranteed to exist forever. It depends on motion, energy, and change. If the universe reaches a state where nothing changes anymore, time itself loses meaning. Without events to measure, there is no before or after. The ultimate future of the cosmos may not be darkness or destruction, but something far stranger, a universe where time stops completely. Right now, the universe is active. Stars burn fuel, black holes consume matter, and particles collide constantly. These interactions create entropy, the measure of change. Time flows because entropy increases. Every process, from your heartbeat to supernova explosions, contributes to this cosmic clock. But entropy has a maximum limit. When the universe reaches total equilibrium, no energy differences remain. Without differences, no processes occur, and without processes, time has nothing to track. This future is called heat death, not fire or freezing, but balance. Matter spreads evenly across space, temperature equalizes everywhere, and motion fades away. Imagine a universe where every region is identical to every other region. No gradients, no reactions, no events. Even atoms barely interact. In such a perfectly uniform cosmos, the concept of time becomes meaningless because nothing distinguishes one moment from the next. Stars will disappear first. Over trillions of years, they exhaust hydrogen and fade into black dwarfs. New stars stop forming because gas clouds disperse. Galaxies grow darker as light sources vanish. Eventually, the sky becomes completely black. But darkness alone does not stop time. The deeper change is the loss of activity. With fewer reactions, fewer events remain to mark the passage of cosmic moments. After stars die, black holes dominate the universe. They swallow planets, dust, and even stray radiation. For unimaginable ages, they remain the last active objects. Yet they also cannot last forever. Through Hawking radiation, they slowly evaporate. The largest black holes may survive for 10 years, but eventually even they vanish. When the final black hole disappears, the last major source of change is gone. Particles continue moving for a while. Protons may decay into lighter particles, reducing matter itself. Over extreme timescales, even atomic remnants break apart. Space fills with extremely low energy photons and neutrinos drifting endlessly. Collisions become almost impossible because distances are enormous. The universe turns into a thin fog of isolated particles separated by an unimaginable emptiness. At this stage, temperature differences approach zero. Energy spreads perfectly evenly. No engine, chemical reaction, or physical process can operate. Every possible configuration has already occurred. Nothing new can happen because there is no energy imbalance to drive change. Physics still exists, but it produces no events. The universe becomes static in practice, even though space still exists. Time requires comparison. A clock measures motion, decay, vibration, or oscillation. But when particles no longer interact meaningfully, no physical clock can function. You cannot count seconds if nothing ticks. The laws of physics may still allow time as a parameter, yet operationally it disappears. The universe cannot experience duration because no measurable transformation occurs anywhere. From an external viewpoint, time may mathematically continue. Equations still contain a time variable. However, inside the universe, no observer could detect it. Every region would look identical forever. Without change, memory cannot form, events cannot happen, and causality has nothing to connect. Time becomes a coordinate with no physical consequence. Some theories suggest quantum fluctuations might still occur. Tiny random events could briefly create particles, but as expansion continues, even these become infinitely rare. Distances stretch faster than interactions can happen. Eventually, fluctuations cannot influence anything else. Each event becomes isolated and meaningless, unable to create a sequence of cause and effect. Eleven in such a cosmos, concepts like past and future vanish. There is only a single frozen state extending endlessly. It is not a moment, because moments require contrast. It is not eternity, because eternity requires duration. The universe reaches a condition beyond time, a final equilibrium where existence has no narrative. Ironically, the universe does not end with an explosion but with perfect stability. Maximum entropy removes all structure. Galaxies, stars, atoms, and even black holes were temporary interruptions in a path toward uniformity. Once uniformity is complete, change stops, and with the disappearance of change, time loses its physical meaning. Any intelligent life could not survive to witness this era. Consciousness depends on energy flow in brains or machines. Without gradients, thought is impossible. Memory cannot update, and perception cannot occur. Observers require time, and time requires change. Therefore, the end of time also means the end of experience. Some speculative physics suggests new universes could emerge from quantum instability. But if equilibrium is perfect, even that may be impossible. The cosmos might simply remain as an unchanging field forever, not empty, not destroyed, just eternally inactive. So when time stops, nothing dramatic happens. No flash, no collapse, no signal. The last event simply occurs, and then there are no more events. The universe continues existing but cannot evolve. It becomes a complete story with no next page. The flow of time feels fundamental to reality, yet it may only be a temporary feature of imbalance. From the first particles to the final fading radiation, everything leads towards stillness. When the cosmos reaches perfect balance, time itself quietly disappears, not because it was broken, but because nothing remains to move it forward.